Okay, so I'll turn this back on. You can see that there's a little green light in there. Oh.
There we go. Yeah.
Oh, I had it.
There we go.
Oh, there we go. Sorry about that. Okay.
Hold it up so everyone can see.
See, there's a little green light there. So the first thing that you need to do is you need to check your voltage coming out. There's a little white screw on the back of all of the units. I don't know if you guys can see that. And that's how you adjust the voltage. So what we're going to do is we just have a little voltmeter here. We're going to switch it to DC. Jack, I'll hold the leads if you want to adjust that, or vice versa. And the voltmeter will tell you two things. It'll tell you what the polarity is. If there's a negative, it means you have it flipped. If it reads as a positive number, then you're okay. I'll show you kind of what we mean here. So black is negative, red is positive. So what I'm going to do is I'll just take this, and you can just adjust. See where it's reading now? It's at 15.02, so that's good. So we don't have to make any adjustments. If I flip this,
Wait a sec, I have to get it small.
well, no, you don't have to. You don't have to make any adjustments. And then if I have this flipped, see how it reads as a negative? So that means that your polarity would be incorrect there because it comes up as a negative number. So that's basically how that works. Pretty straightforward. So then what we're going to do is we're going to turn off our unit here. There we go. So that's powered down. Now we'll run our DC side of it. So do it either way. But this is a pretty convenient little push-down terminal system. Again, you would run it through the back, but we're not going to worry about that right now. So you just push this down, and your wire is held in place. Okay. Now, Jack, I can't really get it from the side. Can you?
Which
Positive this one. I think you just need to tighten it. All right. Tighten it.
What about the jumper thing?
Oh, we can go over that. We didn't do it on this, but no, it's okay.
Can you just explain it?
Yeah. So one thing you guys might notice is that there's two terminals for your negative and two terminals for your positive. And if you're doing like a real installation, you want to run a jumper between those two, and that's in the instructions. And that will help to keep the voltage a little more steady, which will prolong the life of the LEDs. So between your two positive terminals and between your two negative terminals. So that's pretty much it. One thing, try not to look at these directly. If you do stare at them for a long time, you're going to be seeing little white dots. They are pretty intense without a diffuser. So I think we'll just go ahead and put this on. So anyways, this is it.
Those 3-watt LEDs?
Sorry?
Are those 3-watt LEDs?
These are we're running them at about 350 milliamps at 15 volts, so they're about a watt.
Okay.
Yeah.
Whose LEDs do you use?
Nope. This is fine for what they are. This is actually a Nichia LED. So yeah, we don't. So total for the. Yeah, this is actually a little bit more. This is around 56, I believe. What we did is we added a couple more strips in here to get better illumination. That was our older model. But that's pretty much it. And I can't stress, just really go over these points. It seems really simple, but electricians continue to amaze us and screw it up. So
it's that sensitive, that positive and negative. Why not build the safety?
that's something that we're looking into. There are drivers that have that. So yeah, that's
an expensive.
Yeah, it is.
You should safeguard.
Yeah, definitely. I would put it at around, for these I'd put it at around like 70,000 hours.
And nobody knows.
And a lot of manufacturers have actually sort of cut back on their life expectancy. But with this system, one of the biggest issues with LEDs is heat management. And basically what we have is a huge aluminum heatsink built into these, which is it's totally overbuilt. So and there's enough space in here for just a kind of convection thing to happen where the heat will just dissipate. So it's not too big an issue for us. Sorry? Not yet. That's something that we'll talk about this afternoon when we look at our prototype. But that's one thing that's going to be integrated into our new system is a type of dimming. We haven't quite sorted that out yet, but I think that. Basically what you do, I'll turn it off so you can see it. The question was, if one of these lights goes out, what do you do? So what you do is you have to replace the whole strip. And the way to do that is there's two screws here. So you need to remove the screws, and then also there's these little slots here. And you just take a small screwdriver and press it in, and the wire will come out. So you swap it. I mean, you could probably change one of these out in about 15 minutes or something. So.
Any type of picture will see especially
The images for the LED are color corrected for that. They're not the exact same color gradation as you would have for the T5. Our images are designed for the kind of lighting that we'll be used with.
The lighting for this system is a little bit warmer. This is 6,500 Kelvin. With LEDs, it's not as simple as just giving it a Kelvin rating, but this would be correlated to be around that, or around 6,000 Kelvin. And our newer system will be very close to our fluorescent system.
You can show that color correction on that.
Yeah.
Well, should we?